Okay, we have here something today. We want to find the sum of all divisors of 128. Now there is a formula for this, but I like this one because it's going to allow us a way to see the formula just because we've got a pretty simple example here. With 128, this is a factor of only 1 prime. 128 is the same thing as just 2 to the 7th. So to get all the factors of it, it's going to be real easy. We could have like 2 to the 7th times 1. But for 1, I could write 1 as 2 to the 0. So this is going to be the same thing as 128. And then for the next one, we could have 2 to the 6, which is 64, times 2 to the 1. 2 times 64, that's 128. And so we just kind of keep going, incrementing the exponents like this to get all of our factors. So now we have here our 8 divisors. Notice that 8 comes from the exponent on the 2. Just adding 1 to this, 7 plus 1 equals 8. All we need to do is take all these numbers and add them up. So of course we could just punch them into a calculator and get our total, but we don't really want to do it that way. Think about this, instead of having 2, to kind of generalize this, think about it as like an x. So if we have something like x to the 7th times x to the 6th, all the way down to x to the 0 or 1. So this is going to be the sum of all factors of a more general number where it's still going to be just 1 prime, but instead of saying it's 2, it could be anything. This could be 3, this could be 23, whatever. Well, what you'll notice, this thing right here, this is a geometric series. Each term just differs. If we multiply by x, we get the next term. What I can do with this thing, if we just multiply in by 1, multiplying by x minus 1 over x minus 1, if you distribute out this numerator, regardless of what the exponents are, this is going to turn out to be, in this case, it's going to be x to the 8 minus 1 over x minus 1. But in general, without knowing what the exponent is, it's going to be in the form x to the n plus 1 minus 1 over x minus 1. So this is the formula we can use for our problem here, where our n value is going to be this exponent of 7, and our x value is just going to be 2. So we can use this and plug in. So what we're going to get is 2, 7 plus 1 is 8, minus 1 over 2 minus 1. The nice thing about 2 minus 1 is just 1. So all we need to do is calculate 2 to the 8th minus 1. 2 to the 8th is going to be twice this number, or 256. 256 minus 1, and for my solution on it, we just get 255, and that's it. But the nice thing about it is this formula is going to hold for more complicated factorizations. Like if you have, I don't know, something with 2 factors, like let's say just 2 and 3 to keep it simple. Like if we had 24, 24 is going to be 8 times 3. So in order to do this, we just need this formula on each term. So like for the 2 cubed, it's the same thing we just did. We'd have 2 to the 4th minus 1 over 2 minus 1. Then for the 3, we do the same thing, just boosting this exponent by 1. So this is going to be 3, 1 plus 1, 2 minus 1 over 3 minus 1. So again, this cancels here. This is going to be a 2. So we'll have something like 15 here, 16 minus 1. 9 minus 1 is 8, all over 2. Multiply that out and you get 60 for the sum of the divisors of this number, which was 24. So even for more complicated factorizations, the same kind of thing holds when you distribute out everything like this. You're still going to get something in this form, and you can use this formula. Okay, that's it for today. Thanks everyone for watching. Have a good day.